So a couple of Christmases ago, my sister-in-law Jo asked me a question about z-scores, and I didn't have a very good answer, and I don't particularly like to leave things um, unanswered, well, math-wise anyway. And so I'm making this video to right a wrong that she probably has completely forgot about anyway. So let's get on with it. So alright, so z-scores. This is for binomial probability, and you'll recall that binomial probability is really things like heads or tails, true or false, it works or it doesn't. Basically, something happens and something else doesn't. And so what we're going to do is this. If you recall the bell curve, what happens is we're trying to find the probability that something's going to happen. And so I'm going to use an example, and let's say I have 200 students from a town called Northampton. Now, I just went onto the Northampton website and found out that 25%, that's not true, 17.8% of year 6 are obese, which would mean that 82.2% of year 6 students are not obese. And if you're wondering what year 6 students are, I don't really know. It's been explained to me about 200 times, and I still don't know. As far as I can tell, it's the year after year 5. So what I'm going to do is this. I'm going to find out, let's say I had 200 students in this school, and I want to take 25 to 30, I want to find the probability that 25 to 30 of those students are going to be obese. So anywhere between 25 and 30. So here's what I'm going to do. I'm going to use this information here, and I have n equals the number of trials. And so my n for this situation is 200. My p is probability of success, so the probability of an obese student would be 0.178. My probability that they're not obese, or failure in this case, is 0.822. R is a little bit tricky. So I'm going to have two r's here because I have between 25 and 30. So r equals 25. Now, this is my low end. And because of the bell curve, we actually have to use something called the continuity correction. And so you take the low end and you subtract 25. So although my r is 25, I'm going to use 24.5. You subtract half a unit from the low value. And I'm going to have to do this twice. And everything's going to be the same. And you're going to see, this is 0.178. And I'm doing this for a reason. R equals 30, but now, because of the continuity correction, I have to add half a unit to my maximum value. And the reason why is because if we do the bell curve and we're using rectangles, you can see that you miss parts of the value unless you go to the left on this side and to the right on that side. You'll be missing parts. You don't have to do it if your n is very large, but you should do it otherwise. Alright, so before we get started, there's a few things that you have to do. The very first thing that you have to do is you have to check to see if NP is greater than or equal to 5. Here I have 200 times 0.178, and when I do that on my calculator, I get 35.6. So yes, that works. And then you have to check to see if your NQ is greater than or equal to 5. And that's going to be, well, Q is larger than P, so that's going to work as well. So they both check, and so that works. If it doesn't, then using this format is not going to yield a good, a proper result. It may, but it may not. Alright, so the second thing I'm going to do is I'm going to find this first. And what I do is I say, alright, I find my NP, which is going to be my mean. So NP, I just said, was 35.6. And now I'm going to find my standard deviation, which is sigma, by doing n times p times q, so 35.6 times 0.822, and I find the square root of that, and so that value is 29.2632. I find the square root of that, and I get 5.41. I'm going to use 5.41 as my value. Now, here's the last part. I have z equals, and so here's the deal. Your z is equal to x minus np, or your mean, over the standard deviation. So when I do that for this one, I get x, which is 24.5, minus my mean, which was 35.6, over 5.41. And if I do that on my calculator, 24.5 minus 35.6 divided by 5.41, make sure you pay attention to order of operations. My z-score is negative 2.0517. Now, negative 2.05 is going to be someplace right around here. And what I'm going to do is I'm going to find the probability all the way up to here. It's the area underneath this curve. Now, you might be saying, well, how is that helpful? It's not. But I'm going to show you what we're going to do, and we're going to do something else, which is we're going to find this one. And when we use that one, I'm going to have to erase a bunch of stuff. I'm going to erase this over here. I'm going to do the same thing, and I get z equals, and it was 30.5. That's because of that value. Oh, I'm sorry, I should say that's x, minus my mean, which is 35.6, over 5.41, my standard deviation. And when I do this, 30.5 minus 35.6 divided by 5.41, I get my z-score for here is negative 0.9426. So I'm going to say 0.94, which is right about here. So what I just did now was I found the area of this. So what I'm going to do is, because I want to find out the correct area, I'm going to look at my z-scores on my table, and I'm going to take the whole thing, which is this, and I'm going to subtract my red value, which was this, and what am I left with is this value here, which I suppose I'll do in a lovely yellow color, and that's going to be the probability of selecting an obese student between selecting 25 to 30. I have 200 students, finding the probability of getting 25 to 30 of them. Now, here's my z-scores. So let's see, I need negative 0.94. Sorry, I need negative 0.94. So I go here and I'm gonna do negative 0.9, 0, 1, 2, 3, 4, and it looks like it's 0.1736. Is that right? 0.1736. And the other one was negative 2.05. So negative 2.010, 1, 2, 3, 4, 5, 0.0202. And when you subtract them, you get 0.1534. Now, if you have a TI-84 calculator and you want to do this, you would press second in bars, and then you'd select normal CDF,
And after you
It's like
can.
normal CDF. And you enter in the lower bound, which is 24.5. The upper bound, which is 30.5.
How do you get off
The
this?
mean.
Hey, how do you get off this?
What's that, Benji?
How do you get off this?
The mean, which is
How do you get off this then?
35.6. You press clear. The C.
Clear?
Yep. And then you enter in the standard deviation, which was 5.41. And you press enter.
He does a 0 there.
And when
Now,
you
why
do that,
is the 0 there, Dada?
oh no, I got something completely different. Let's try that one more time.
Why is the 0 there?
24.5, 30.5. My mean is 35.6. My standard deviation was 0.41. Oh, good. I get 0.15667485. Now, although this is probably a more accurate answer, you'll notice that this is about 15.67%, and this is 15.34%. Yes, I am off, but you can see I'm off by less than 1%. I'm off by less than half a percent. So anyway, I hope this has been useful. The trick is knowing how to plug the stuff in. Oh, also, if you just want to do up to 1 unit, your lower bound would be negative 0.5, and then your upper bound would be whatever it is plus 0.5. And that's it. Enjoy. Oops. Oh, and to get the z-scores, you can go to www.regentsprep.org, Algebra 2, Stats, and then I believe it's normal distribution or something like that. Alright, that's it. It's a bit of a mess here.